Today's problem from particle dynamics, and this is from the vertical motion of a particle under gravity, right? And the problem says that a particle projected vertically upwards with a velocity u is meets with a resistance which is k times the square of the velocity, right? The greatest height attained by the particle is given by 4 options. We have to choose the correct option. Okay. Now we try to solve this problem by a rough sketch. Let this is the base, or this is the horizontal line from where we project the particle vertically upwards. Okay. With velocity, here the velocity is u. This is the velocity, upward velocity. And we know that when we project a vertical upwards, then there are a gravitational force which act vertically downwards. So in this direction there be gravitational attraction which is Mg, right? And let it be O, and let the particle be at P at any time t, where OP this is x. Okay, and here it is given that this is a resisting medium and offers a resistance with k times the square of the velocity. So resistance always act opposite to the motion. Since the motion is upward, so here resistance force we say R, this is k into v square per unit mass. So we multiply here by m. Okay. Now we write down the equation of motion of the particle when the particle be at P. The equation of motion is given by m v dv dx. This is mf, this is the acceleration, and the right side is minus mg because mg act opposite to the motion. Also this is minus m k v square. This is resistance force. Okay. Now cancel out m from both sides. We write the relation as v dv dx. This is g plus k v square. Okay. And let this is the greatest height, where the greatest height is capital H. At the greatest height, here must be u, sorry, this is velocity v, this is 0. Okay, and at that point, if this is a, that point x is capital H. Okay, and initially it is given that v this is equal to u and x this is equal to 0. Okay, so we get from this relation as v dv by g plus k v square, and taking integration here, and on the right side we also take integration dx, and the integration dx is given by from the range x equal to 0 to capital H. This is x equal to 0 and this is x equal to capital H. And for the range of the left side, here initial velocity is u, this is capital U, and at the highest point or the greatest distance, here velocity is 0. Okay, now to integrate we put g plus kv square, this is equal to z. So we get 2kv dv, this is equal to dz. So v dv this is equal to dz by 2k, right? And getting the result as, also we get the range of integration, this is u, sorry, this is v and this is z, this is u, this is 0. When we put v equal to u, then z equal to g plus ku square, and when we put v equal to 0, then we get g, right? That is, we get g plus ku square, and upper limit is g, and this is dz by z. And from the right side we get minus h. We directly write by integrating. Now the integration of left side is given by log z, and the ranges are g plus k u square to g. This is equal to minus h. So the greatest height h, this is given by log g plus k u square minus log g. Okay, and we make a small mistake here. Here must be 1 by 2k. So 1 by 2k is also here. So we write 1 by 2k. And we adjust here minus sign. So we write in the opposite direction. This is minus and this is plus. So our answer is 1 by 2k into log of g plus k u square by g. Okay. So 1 by 2k into log 1 plus k u square by g. And our correct option is option number A. Very interesting problem from the particle dynamics, and this is very easy problem also. Thank you for watching.